In our last video, we looked at conditional statements. In this video, we are going to continue looking at conditional statements. We're going to start by looking at the truth table for a conditional statement, P implies Q. So with a conditional statement, remember those are an if-then statements. If we want to create our truth table, we have all of the options, potential options for P and Q. We could have true and false, true and false, false and true, or false and false. And so when we look at P implies Q, if our premise is true, then something that is true, if it implies something else that is also true, then we would say you have told a true statement. However, if we start off with something true, but then our conclusion is false, then we have said something false. So, if I am a math teacher, then I teach math classes. Yeah, that is a true statement. If I am a math teacher, then I teach math classes. Right? The premise is true, the conclusion is true, that if-then statement is true. If I were to say, if I am a math teacher, then I work on the moon. Right? The premise is true, the conclusion is false, and so you'd say, that's not true. Just because you're a math teacher does not mean that you're going to work on the moon. Right? If you start with a false premise, though, if your if portion is false, then whatever conclusion you make is ultimately true. Not the conclusion is true, but the overall statement, the logic of that statement is true. If it's 1,000 degrees tomorrow, then I am going to jump over the moon. Right? It doesn't matter what conclusion I make. If the premise is false, you're like, yeah, sure, that's fine. So if we start with a false premise, any conclusion is going to lead to an overall true statement because we didn't start with anything true to begin with. So the only time our if-then is going to have a false is if we start with something true, a true premise, but come up with a false conclusion. So that's our truth table for the conditional. So let's make not entire truth tables here, but let's look at some portions of truth tables. Let's assume P and Q are both false, and Q is true. We're going to find the truth table for not R implies P. So we're just looking at that one row. We're looking at the row. We don't need to identify anything about Q in this problem. We know a value for P. Our value for P is false. The value for R is also false. So then not R is going to be true. And if we were to go not R implies P, we have true implies false. So we're saying this implies this. We're looking at essentially this row from up above, and so we should end up with a false conclusion here, or a false value for that conditional statement. On the next one, we have a more complex statement. So we have our options for P, Q, and R. So again, from up above, we know that P and R are false. So this is false, and this is false. The value of Q is true. Right? So those were provided up here. We're starting with those. We're only looking at this row of the truth table. We're going to need to find the value of not P. So that's just the opposite value of P. So since P is false, not P would be true in this row. We need to find the value of Q and R. So Q and R. So we have here Q and R. The AND statement, it will be true only if both pieces are true. So everything else is false. We have something true and false. So that should give us something false. And then our if-then portion not P implies Q and R. We're looking at this row compared to this one. So true implies false. That, again, is this row in the truth table from above. And so that is going to result in a false. Perfect. So that is truth tables for the conditional, for that if-then. In our next video, we're going to look at tautologies. So we'll define those, and we'll look at some things, try to decide if things are tautologies. We will see you there.